So just a little bit of information on Metro structural assets. We're responsible for nearly 1,500 bridges for routine inspections, which equates to over 27 million square feet of bridge deck area, 1,800 overhead signs, 900 retaining walls, and 120 miles of noise walls. Within Metro, the district is split up into 6 bridge sub-areas, and each sub-area is responsible for approximately 200 to 250 bridges, with a crew size of 7 to 9, including the supervisor. This is just a snapshot of our current organization. It's divided into 3 different areas: bridge scoping and programming, bridge maintenance under the superintendent, and then bridge routine inspections. And what I wanted to point out with this organization is the certified team leaders. And so right now we have our bridge maintenance supervisors and our crew leaders are all certified team leaders. And we want that to be able to respond to incidents. So I'll talk just a little bit about some roles and responsibilities within Minnesota. We have bridge inspection team leaders, and they are certified by MnDOT through a proficiency test to conduct inspections of in-service bridges. And of course, they go through, the Federal Highway Certification Program or training program and have experience. But they're also certified with a field proficiency test within Minnesota to be able to become a team leader in the state. And they must be present. Team leaders must be present at the bridge site at all times during a bridge inspection. We also have program administrators, and a program administrator is a certified professional engineer. They're appointed to oversee the bridge inspection program within the district. The program administrator must review and approve every bridge inspection report, respond to critical findings, and also respond to any other inspection findings during a routine inspection report. A couple years ago, we started developing an incident response procedure for bridge hits. And so we defined incident as anything that could affect the structural integrity of the asset. And then for response, we want to be able to dispatch the appropriate personnel and equipment to be able to respond to that incident. In some cases, when dispatch would receive a call, the highway maintenance supervisor would become the first point of contact. And we really wanted our bridge maintenance supervisors to be that first point of contact, to again get the certified team leader on site to be able to assess the damage and determine if if an engineer was needed on site or what sort of repair actions were needed. And so for response, we want to make sure that we activate those communication links, because communication is key, right? And then we have to document and report those findings. So within our SIMS bridge inspection program, then we have damage reports and we have critical finding reports, which I'll show a little bit later. And then we need to prepare and implement any sort of necessary repair action. So within our response procedures, we've identified this response protocol. So again, if there's an incident, it goes through dispatch, and then we want that first point of contact to be our bridge maintenance supervisors, who are certified team leaders. We may need the highway maintenance supervisor out there to provide traffic control or other needs. If the supervisor is not a team leader, and that happens in a couple of our districts, then they would call out the team leader. If an engineer is needed to assess the structural damage, then the engineer would be called at that time. If additional analysis is needed, then the bridge office is brought into the discussion, and then we document our reporting through SIMS with a damage report and or a critical finding report. For a damage inspection, we need to assess any damage, and we need to report it within our SIMS database, and we look at information, the date, location, any equipment requirements that we needed to inspect that damage, and then what were the inspection procedures, the components that were damaged, and what the findings and recommendations are. This is just a snapshot or a screenshot of our SIMS damage report. If the asset condition is deemed critical, as defined by the NBIS, then we need to report it as a critical deficiency. And then that gets reported to our bridge office and also to FHWA. Within the critical deficiency reporting, we have 3 different sections. The first part is completed by the inspector, and it's really like a location and then a description of what the damage is and what the critical deficiency is. Then the second part needs to be completed by the program administrator, who oversees the inspection program, and document an anticipated plan for that bridge or for that damage. And then parts 3 and 4 then look at the description of the final action taken, and that's filled out from our bridge office. Here's just an example of the part 1 from our critical deficiency reporting, and you can see it kind of, again, looks at what the reason is for the report, what is the description of the critical finding, and then looks at the NBI ratings associated with that. And then within parts 2 and 3, it looks at the program administrator's plan for that bridge to address the damage that was found, and then the bridge office, looking at the description of the final action taken. After the incident and the damage is assessed, then we have to look at repair options. We could repair by our in-house forces, or we could repair by contract. We could repair by contract through kind of some of our regular methods, design, bid, build, or negotiated contract. We could also repair through a state contract, where we have a contractor on retainer to perform specialty services such as heat straightening. Or we may have to go the route of an emergency contract if it's something that impacts the safety of the trunk highway or the roadway above the trunk highway.
We're going to go through some of the responses using the topics that Sarah's talked about. This is kind of a history. This is the first bridge in my examples. It's going to be 9039, which is West 86th Street over I-35W. I-35W is a main north-south road to go in and out of downtown Minneapolis to the southern suburbs. It's a 6-lane interstate. It has approximately 12,200 ADT. This bridge was built in 57 and was refurbished in 96. It's a 4-span continuous multi-girder with welded steel cover plates. It's a simple span approaches with a continuous center span. And the first hit that we're going to be describing occurred on January of 2015. A lowboy carrying a backhoe traveling southbound hit beams 9, 2, and 1. In Minnesota, we number our beams and piers and abutments by what direction the bridge is. So in this case, the bridge is running east-west. The south fascia is beam 1. There's 9 beams there, so the north fascia is also beam 9. Just to give an idea where we are talking when we're communicating to everybody in the design office or in the district. The beam 9 was also rotated out of alignment 28 to 34 feet, which is basically the right shoulder, right lane, and the center lane of the southbound lane of I-35W. It also hooked beam 1. There was a pre-existing, from a previous hit, tear in that vertical stiffener. If you look at the right picture there, that tear was approximately 3 inches in length. It extended it to a 9-inch smiley face. It also caused propagation of the existing cracked tack weld in the bottom of beam 1. And on the third hit, that occurred in June of 15. A similar story, a lowboy with a backhoe traveling southbound in the right lane, hit beam 9. He rotated this beam out, again, 28 to 34 feet. He also crushed the beam stool, and the shear connectors lost composite action with the deck. The reason that there is no second hit, excuse me, is that's going northbound. When we did the initial investigation, looking through our reports and records on this bridge, it had been hit 10 times in 10 years, and I don't know why. I really don't know why. That's the ones we could keep track of, let's put it that way. We found numerous other ones that nicks and cuts when we actually were looking at the inspection. The fourth hit, you can see the running theme here. This happened in February of 16. Again, southbound, backhoe, right lane. This time the backhoe's knuckle got beams 9, 8, 7, 2, and 1. The picture on your left is beam 9 and beam 8. The straight line in the middle is a 10-inch natural gas line that feeds the suburb of West Bloomington. Actually Bloomington, but it's the west part of Bloomington. It occurred in the same identical location as the third hit, only it caused more damage to the beam stool and the shear connections. Also on the picture on your right, you'll see that it pretty much tore apart the diaphragms inside. And the picture on the upper left there is the fracture of the 10-inch natural gas line. Fortunately, that line had been diverted. There was still natural gas in it, but it was not under pressure. This line has previously been punctured under pressure, under traffic, at 4 o'clock in the afternoon. We will not describe the mess that had. The line was, as I said, the line was capped that day by CenterPoint Energy, and then it was removed approximately 2 weeks later. And the picture on the right there is that day, 6 lanes of interstate at about 2 o'clock or 3 o'clock in the afternoon, the freeway is shut down. And it's the guilty party there. We were able to open up northbound, and then we opened up southbound approximately 5 hours after the initial call that I got and went out to look at. The fifth hit is a 2-for-1. That occurred in April of 17. This one was a lowboy convoy carrying storage tanks, and we found out it was from North Dakota. Thank you, by the way. They didn't have a load permit. We found out that the first truck went through, didn't hit any of the bridges. Second truck went through. This is 9213 is 82nd, which is just north of 86th. Somehow he caught the south fascia and then rotated that beam out of alignment 34 feet, tore the vertical stiffener, and he also, that engagement by hooking that beam caused the beam stool to crush and then the shear connectors to pop out of the deck. And the background on 82nd, very similar in design to 86th. It's again four-span multi-beam structure, same type of design with the welded cover plates. It was built in 57. It was remodeled in 1995. The vertical clearance on this one was approximately 15.3. The vertical clearance before adjustments on 86th was about 14.8. We signed a MnDOT at 14.5 and below. And the initial response for 86, it was reported as a critical deficiency after the fourth hit. We closed the outside lanes above on the 86. 86 was a 4-lane street. It became a 2-lane street. And then we closed the bridge after the fifth hit. That fifth hit was a scrape because they'd already been moved. The bridge had already been raised slightly again because of all the other hits. So we just, as a side of caution, because all the damage that bridge has taken, we decided to close that bridge. And because we were going to be replacing that bridge in 2017 in July. 82nd went right to a critical deficiency. We closed the eastbound lane and the sidewalk as a precaution. We had to investigate repair options for 82nd. Could we add this to the existing contract for 86th? Unfortunately, we could not. They're just outside the project limits for construction. We kind of went begging or pleading with our construction group, and they said no. Okay. Could we heat straighten the beam on 82nd? And we made the determination that no, the best way was to replace it because of the shear stud problem. And then we had to find a beam, and it's like we thought maybe, well, we've got this other bridge we're taking down. It's from 57, same design area, same type of beam. We could use that. We did a field investigation, Sarah and I and some other engineers were out there, and we realized there isn't a beam on 86 that isn't banged up. We can't use it. We have to buy one. Finding around a suitable beam that would, in today's steel manuals and today's design codes, that would fit.
I just want to add one more thing too on 86. The other concern was from the contractor standpoint, we were doing removals under a weekend closure and trying to salvage a beam under a weekend closure, again with the very highly trafficked area with 35. The contractor was not very excited about trying to salvage a beam with a weekend closure.
So we ended up doing an emergency authorization for 82nd. We worked with the contractor fortunately we were able to work with the contractor on 86th. The company I should say, we developed a replacement contract. We did a rough work plan and estimate. The picture here is the beam removal of 82nd. We did that approximately the same time when they were removing 86, so we don't impact the highway that much. We ordered a new steel beam, and then we had proceeded with the emergency authorization. The removal was in July 17. And the night closure, the beam placement for 82nd was in September approximately. 86 beams, I think, were set in August or September. And the deck pour for 82nd was in October of this year.
And one of the goals was just to utilize the traffic control that we would have set up for 86th Street. And we had to add a little bit more on top of 82nd and kind of extend that lane closure. But that was one of the ideas, is when we're closing 86 to replace it, let's remove that beam. When we're closing 86 to place beams, let's place that beam. You know, to again try to minimize some of the traffic impacts.
Yeah. And this is a little bit of equal opportunity. We have pre-stressed beams. We don't just have steel. This bridge is 9733. It's 35W over Lake Street and just shy of downtown Minneapolis. Lake Street is a major east-west road in Minneapolis. Overheight roll-off container truck left his rams up. It's probably a familiar story for a lot of you people. And he hit the east fascia, beam 1. He damaged it, delamination, spalling, stirrup bars were cut, the strands were cut. On the inside of this, on the flange and the web, the concrete was fractured into approximately 12-inch blocks. If you will notice up in the upper left there, you'll see that there's an MTC bus on there. That is an off-on ramp stop for the buses right there off the freeway. That wheel path for that bus is approximately 2 feet from that girder. That particular bus stop was closed within 5 minutes of our inspection at that time for safety. City of Minneapolis also responded, so thank you very much. Yes, unfortunately, I don't know if you heard it, the driver of the truck did not have his seatbelt on. He went through, it was a cab over. He went right through it. And he had severe injuries. He lived, but he was okay. So my little pitch for safety is just wear your seatbelt. And we don't have just bridges. We do occasionally get other weird things. This is an overhead sign bridge over by County Road C on 35W again in the northern suburbs. This is southbound. A semi-truck was forced to avoid a car on an off-ramp to going to County Road C. He ended up going through the guardrails. And if you see the gentleman in the picture on the right with the vest on, you look to the left of that picture, that black smudge flat part, that's what's left of the tractor for the semi. It completely engulfed it. Fortunately, in the background, the people from the car dealership were able to pull the driver out. He just suffered third-degree burns on parts of his arm, and that was all. He lived. We made the investigation and decision based on the pylon that's shown in the picture on the left there, the fracturing at the foundation, the heat generated by the fire. I'm not a metallurgical engineer. I'm a civil engineer. I guess I erred on the side of caution to pick the sign. Now it comes the problem is how do we pick this sign off, because our crews do not have those kind of cranes. The wrecking company was already out there dealing with the semi-truck. They said that their wreckers are booms, they can pick it. They asked, how heavy is that? I made a quick call and they said 20,000 pounds. I said, what's your capacity? They said, 20,000 pounds, or it was either 20 or 30,000 pounds in the boom. I go, get 2. And they picked it, put it on a flatbed, and we hauled it away to a park and ride. Then our bridge crews came in, and with oxyacetylene torches, we cut down the west pylon for safety. Our maintenance crews then put in temporary water-filled barriers around that area, and the freeway was opened up approximately 7 o'clock that night. The accident occurred approximately 2 o'clock in the afternoon.
I don't have any questions for you, Mark, but I would like to add some of the history and some of the incidents that does happen throughout the state. It is a big issue for us. We typically get a bridge head about once a week. I don't know what other states kind of experience, but it's usually about once a week. Usually 1 to 2 a month require some sort of analysis. So that's kind of the overall picture from a statewide perspective on the bridge hits.
It's my impression and experience in the state of Wisconsin that we're progressively seeing more and more hits on the bridges, that it's not slowing, and even with our upgrades over the years and vertical clearances and stuff like that, we're seeing more and more, and maybe that's the result of the freight industry. Is that your experience too, or other states? Is there anyone who's not seeing more hits, that it's been constant for about 5 years? And we're seeing quite a surge really in the relatively short past. What are your thoughts on that?
In my opinion, and this is my opinion for that, within the Metro District, what we've seen is a sense of hurried up and by the driver of the truck, get back on the road, not securing his load properly. In most of these cases, the backhoe knuckle or the bucket isn't tucked all the way down, therefore the knuckle up by the cab is high, and that's why you hit. In the pictures that we saw in the video that was presented yesterday, the knuckle was high, that's why you hit that sign, blew that sign out. That's pretty much our experience. It seems like that. They're just too hurried, they don't check, they don't measure. A lot of human error factors. We've had numerous stories where they're careless.
So we're kind of struggling with how do we do outreach to industry. Do you do any outreach to share with them, the reoccurrences or to try to head off some of it? Is there anything you all do in that respect?
Ed, you can maybe respond
Ed.
to that. It's through our permitting, I think.
We have a MnDOT permit office that issues permits for oversized, overweight trucks, and they do have an outreach with the social media site to update that. And we also have all of our bridge vertical clearances on our website. So any trucking association can go on our website and download all the vertical clearances for all the bridges we have in our inventory. So that's the kind of information that we give out to them. But we have, from a statewide perspective, we have noticed that slight uptick in the number of bridge hits, but it is in our risk analysis for BRIM as the vertical clearance and the number of bridge hits, and we do track that. And so we do look at that as we're replacing bridges and looking at bridges to raise and different things to do work on, as that would be one of our criteria and the number of bridge hits. So, because we've raised bridges that are at 17 feet, right? Because they keep on getting hit, even that high. So we look at that incidence and track that.
Discuss these issues. Thank you so much, Sarah.
Thank you.
Mark.
The preceding video was produced by the National Center for Pavement Preservation. More information can be found at tsp2.org. That's tsp2.org. Additional support provided by Michigan State University.